Hi, everyone. So we've talked about climate controls on a global scale. Now we're going to look at climate controls on a regional scale or on a national scale. We're going to do a study of 3 different cities and the climate controls that impact their precipitation in those cities, just precipitation. And when you think about impacting precipitation, you're thinking about the climate controls that directly impact precipitation, which include the pressure systems, because remember, rising air produces precipitation, especially around the equator or in around the 60s. And you're also talking about topographical lift because you've done the lab work on the rain that falls on the windward side of the mountain and the rain shadow that is on the leeward side of the mountain. So those are the climate controls that we most associate with precipitation. In this case, for these 3 cities, topography is not that big a deal because most of these cities are in flatter areas or near sea level. So yes, San Francisco has a lot of hills. It's going to be a little bit more impacted, but it is at sea level. And the same thing, Kansas City has a very flat area that it's on. And when we're talking about Baltimore, we're talking about sea level as well. So in that respect, if you mix topography, then you're really looking at pressure systems for producing that precipitation differences. And when you think about pressure systems, you think about that rising air at the equator and at the 60s. Well, we're not at the equator and we're not at the 60s. So what pressure systems impact our cities, which are all along the same parallel? They're all along the 39th parallel of latitude. And what's interesting about that is because they're very close to what we call the Roaring Forties. And it's called the Roaring Forties, especially among sailors, because anything can happen in the 40s. You have a subtropical subsistence high in the 30s, the horse latitudes. In the 40s, all bets are off. There's a lot of mixing in the atmosphere. And you're noting that in these cities here, that these pressure systems are changing and producing different precipitation results. Let's take a look at them a little bit more closely. When it comes to San Francisco has a precipitation maximum in the winter. Well, why is that? Why do they have the most precipitation in the winter? It's actually due to the impact of that subsistence high at 30 degrees. That subsistence high at 30 degrees is quite broad on the Pacific. In the winter, that high moves south because the heating that also moves south as well. So you've got a lot of polar air pushing that 30-degree subtropical high further south and then leaving San Francisco exposed to storms that come racing through the Pacific. We have talked a little bit about, or maybe you've read about, the Pineapple Express. And that Pineapple Express comes right out of Hawaii and dumps a lot of water into the winter areas around Northern California when that subtropical high moves south with the sun and with the polar air pushing it down. So that's what happens in San Francisco. Now let's talk about Kansas City. Their precipitation maximum is in the summer. Why is that? Well, that's due to the difference in land and sea distribution in Kansas City. There's no sea around Kansas City. It's all land. And when the summer hits, that land will heat up very quickly during the day. And you know what happens as a result of that. That land hits up very quickly. There is a shallow low right over the surface that convects up. And suddenly now you're convecting a lot of air up into the upper atmosphere. That air also tends to be very moist because during this summer, that high that migrated south a bit migrated right into the Gulf of Mexico and is able to push up some moist air out of it, because you know that highs migrate out, and some of that moist air can come right up the Great Plains to Kansas City. So now you have convecting air that's very moist, setting the stage for thunderstorms. That's why Kansas City has maximum precipitation in the summer. What about Baltimore? Baltimore is a lot like New Jersey, very close by, and they have a very even current of, they have a very even level of precipitation throughout the year. Why is that? That is because of the Gulf Stream and the ocean currents that provide a continuous stream of moist air with the Coriolis effect as it's going in that right-sided direction up from the equator. So there you have climate controls that move a bit across an entire nation and can produce different climates. And next I want to show you how climates are changing a bit. Oh, no, sorry about this. I wanted to explain this to you. If you ever get a chance to go to Olympic National Park, go, and go sooner rather than later. A magnificent place to visit where you can literally see climates change within miles, based partially on topographical changes, because you have some very high mountains right off of the ocean. So you do have some land-sea distribution issues there and topographical changes. You also have the ocean currents and that moving high that moves from summer to winter off of the Pacific coast. In case you're wondering, Olympic National Park is in Washington State. So a beautiful place to go. They have rainforests literally on the slopes leading up to these Olympic mountains. They have glaciers in the Olympic mountains, and then they have a rain shadow out in Port Townsend, which is the town where all the ferries go out of because the weather is so fair, and the ferries can go out to the San Juan Islands and up to Vancouver. So a magnificent place to go to visit, one of the most diverse areas in the country for our climate, and certainly a very important one to visit. And now you understand what climate controls factor into Olympic National Park. When we talk about classifying these climates that we're seeing by precipitation and by temperature, we are talking about the Köppen classification system, which is over 100 years old, but still very relevant. And it has been a theory that has been adapted and modified and updated over these past 100 years. Vladimir Köppen is a German scientist who wanted to classify areas of the globe based on their temperature and precipitation and their related vegetation. So he was able to classify these areas that he was never able to visit. He did not have climatological data for it, but his classifications proved to be quite accurate. He divided the globe into 6 climate types: tropical moist climates, dry climates, moist mid-latitude climates with mild winters, that's New Jersey, moist mid-latitude climates with severe winters, that's up in Vermont, and polar climates farther north, and highland climates, which we are talking about when we talk about topographical change and the Rocky Mountains and some of the Appalachian Mountains. When we look at the Köppen classification system on a global level, you can see that he looked at climate controls that we've already talked about. You can see that he was looking into pressure systems. You can see that he was looking into ocean currents. And you can see that he was looking into topographical ranges as well and mountain sides as well. So you're getting a feel for that. These wavy lines, for instance, are in the intertropical convergence zone, so they're another pressure system. You can get a feel for his different classifications by color as well. So here are his 6 areas, you can see that New Jersey is right in here with the moist, mild winter. When you start to get into Vermont, you start to get into the moist, severe winter, and you start to get into the highland areas as well. So this was the original 1918 classification. Since then, they have added on other classification systems as well, and we're going to go over that in the next video. See you there.